Welcome back to Spark and Solve with Solex. Today, we're stepping into the chemistry lab to perform one of the most important practicals you need to master: acid-base titration. In this practical, we'll use acid-base titration to determine the concentration of an unknown solution accurately. Our goal is to find the concentration of the unknown solution by reacting it with a solution of known concentration. Here are the apparatus and reagents we'll need: a burette, pipette, conical flask, indicator, and our standard and unknown solutions.
We'll also need a volumetric pipette, conical flask, pipette filler, phenolphthalein indicator, and our two solutions.
The burette measures the volume of solution delivered during the titration. It must be held firmly and vertically. Our standard solution is sodium hydroxide, NaOH, while the hydrochloric acid, HCCl, is the solution whose concentration we want to determine. First, rinse the burette with a small amount of the solution that will be used in it. This prevents dilution of the standard solution. Allow the rinsed solution to drain completely through the tip, then discard it. Do not return it to the reagent bottle. Now fill the burette with the standard solution. Make sure the solution fills the tip and there are no air bubbles. Remove the funnel before titration and check the tip carefully. Make sure there are no air bubbles. Next, adjust the solution level to the 0 mark. Read the bottom of the meniscus at eye level. Always read the burette at eye level. Record the bottom of the meniscus carefully to avoid parallax error. Next, rinse the pipette with a small portion of the unknown solution. This prevents dilution when the measured sample is transferred. Now use the pipette to measure exactly 25.0 milliliters of the unknown solution, aligning the meniscus with the calibration mark. Transfer the 25.0 milliliters into the conical flask. Allow the pipette to drain naturally without blowing out the remaining drop.
Add 2 to 3 drops of phenolphthalein indicator and swirl gently. The acidic solution remains colorless.
Everything is now ready. Place the flask under the burette and prepare to begin the titration.
Open the stopcock and allow the sodium hydroxide to flow into the flask while continuously swirling the solution. Keep swirling continuously so that every drop of sodium hydroxide reacts completely with the acid. Notice the color change. At this stage, the pink color disappears as the solution is swirled. Disappears as the solution is swirled.
As we approach the endpoint, slow the addition and add the sodium hydroxide more carefully while continuing to swirl.
Near the endpoint, add the sodium hydroxide drop by drop, swirling after each drop and watching the color carefully.
The endpoint is reached when one final drop produces a faint pink color that remains after swirling. Swirl gently and confirm that the faint pink color persists. This confirms our endpoint. Now read the final burette volume at eye level using the bottom of the meniscus. Our final reading is 24.70 milliliters. Record the final burette reading, then subtract the initial reading. Here, our titra is 24.70 milliliters. The reaction is a 1-to-1 neutralization. Hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. Using C1V1 equals C2V equals C2V2, the concentration of the hydrochloric acid is 0.0988 moles per liter. And that's how we perform an acid-base titration. Keep learning, keep solving, and follow Spark and Solve with Solex for more practical lessons like this.